throughout the course, all of the chapters, if you don't continue, for example, you are coming from middle of the chapter, you couldn't understand anything. So that's why, if you couldn't come to class, you should watch the videos. After that, if you come to class, you can understand.
Yeah.
Otherwise, you don't understand what I'm talking about. So, if you remember, we reached to two value of value and the Q value. What was the value? Imagine we are in a state. So, what are talking the value of policy and state? It say if we are in state S, for example, we are here in the room, and we follow the policy. After that, what is the total of the reward we expect to achieve? That's the return of the function of the value. So, if we want to remember what is the policy, for example, here, this is the random policy. It means we are here, we are going to these 2 points in the star. So, in the random policy, going inside has the same probability. But in the optimal policy, if we are here, to go the destination, the best place to go in this place, means going up. So this is the best policy, optimal policy. That's our policy. So what's the value function? Value function say, for example, we are in here, in this state, and we follow this policy. So what is the expected total reward we may achieve? Return us the total of rewards. That's the value function. And what is the Q value function? Q value function say, if we are in this loop, this state, and the first action we know, for example, first action is to go left. So, Q function return us if we are in the state S and the first action is action A. In that case, the total reward we expect to achieve. So, if you want to have a relation between Q and a V, Q value and just V value function, we say, for example, we are in state S, so, and our first action is A. This is the QSA. That's the total reward may be achieved starting from S and first action going left, A. So, now we want to write this with the V function. We say, when we are in state S and go left, that has a reward plus. Then we are in state S prime, that we reached going from S with the action A. Left, for example. Now, via S prime means starting from S prime. What is the total rewards we expect? So the relation between Q and V is that. When I say it or not? It's difficult to say.
No.
If you can, come and say in Arabic.
Bilmem diyorum.
Huh?
Bilmem.
So, we continue. Or in English, even in English you may say, if you have any question, you say, you see, we go on. If you have problem, you don't ask. So we finish the chapter. So if you have any question, you may ask. If you don't have any question, means to understood. So come here and repeat.
يقول متفق معكم سؤال توصلون من هذا
So we go.
معكم سؤال فاسألوا اللي عندكم هنا حتى تحضرون الامتحان وبعد
الامتحان شنو تصير
بعد ما ناخذ من هذا اصلا.
وهاي يسموها درست انه اكو ازاحه واكو رسم مجموعه؟
لا يرسل الفرش.
لا دوام.
يرسل الفرش. هذا عندنا المعادلة
اي
المختصرة.
بس كمان
هاي تميز عن مجموعة.
زين بين المعادلات بين تطبيق رياضي ولا فقط معادلات؟ لا اكو شنو قصدك اكزامبل؟ اكيد.
So now we are talking about trailing courses. So this is the QSA, means the total reward that we can achieve starting from state S, and the first action is A and the policy is B. So that will be total reward. Then we have a equation, the name is Bellman equation. What it say? It say the QSA is equal with the first reward we achieve plus, don't consider gamma, we will talk, the reward we achieve after that. So we are in state S, we want to find QSA. What is the QSA? Starting from S, and we know that first action is going left, action A. In that case, what is the total reward we expect to achieve? So we say that's equal with when we go left with the first action, what is our reward for the first action? Plus, then starting from S3 and try all actions. For example, in the game I showed you in the previous slide, action is going up, down, left, right, 4 actions. So starting from S3 and try 4 action and find the best action for the first one after S3. What is our total reward? So it's the same. So means, I repeat here, starting from S and first action is A, what's the total reward we expect? Is equal with first reward plus the total reward we can achieve starting from S3, the next state, and try all action for the first action starting from S3 and find the maximum reward. Which of them is the best? Choose that and say after S period, starting with the first action of A period, that's the best of the 4 actions. What is the total reward we will achieve after S period? So these are the code. That's very logical.
Okay.
So we have a table. In the table, we have the QSA values. At the first, we randomly initialize. So at the first, this equation will not be true. Then we try to make it true. How? We make the difference between them less and less. So that's when we reach to a state that the table is the correct, means this equation is okay in the table. That's the training process. We will see. So we say Q S A minus reward plus mod, we will talk about gamma, max, A green, S green, I green. Then we can write this S, write this S next, and next is.
Okay.
So, when the table is trained, this will be equal. So now, how we train the table, we say, what is the difference of this? We add this difference to Q S. First is no difference, but usually they do this. But no difference, this is difference.
Okay.
One of them positive, one of them negative, is the difference between them. So, then we add this to this one. We say as much as we have difference, if we add that difference to this one, after that, it will go on to reach a point that this equation be true. But in the training, we have a training learning value or step size. Means to go, we go slow by slow. In each step, a little bit we improve it. So, we call it alpha. Here it is. So, we say the new value of QSA will be this. So, we will solve an example for this. Imagine the alpha is 0.5. And what is the gamma? Of course, we told earlier in the first sessions, but I repeat. At first, imagine the gamma is 0.5. So, we say the first reward in first action plus we multiply gamma on the second reward plus we multiply gamma power 2 on the next reward. We multiply gamma power 3 on the next reward, and so on. So at first, we have total of reward 1 for the first action. For the next action, we make it half and then communicate. It means add 2 rewards, total reward. The next, we will have the quarter of the reward 3, not all of it. Then we make this one, it will be like this. So, as we go on, this value became less and less. So that means for the total reward, the first reward has more effect on the total reward. We are going to select a way in a game. We say, make the far choices is very far, so we don't have any good information for them. So for the first choices, we are more comfortable, more accurate decision. So we give to reward of first actions more weights. So that's the goal. Now we solve an example for this, and we imagine the gamma is 0.9. Imagine we have such a table. And we are starting from a point and we reach to a destination. Imagine the destination is this point. And when we go in any room, we get the reward -1. Means any movement have the reward -1. Why we use it? Because if we are going to this point, we circle here 100 times, then we go here, it will take more time, so that is not good. To force the algorithm to reach in the fast time as quick as possible, we give reward -1 for any movement. And when we reach to destination, we give reward 10. Means if the agent reached the destination, got the total reward is 10. So then reach the destination, get reward 10. So we do like this. For example, in this room, it means when we put a value here, it means we are in this room and we are going right. Our action is going to right. We have four choices here because we have 4 actions. Going right in any room. Going right, left, up, and down. So, at first we put 0 for all of them. We imagine QSA is 0. So all of them became 0. Then we starting to train this. Imagine we start from this room, and imagine at first we go right. That means we are finally into this room. So we write QSA is previous QSA plus 0.5.
Okay.
Then R. What is the reward to going right? Minus. Because any movement is -1.
Minus.
For all rooms except for this one, that's 10.
Okay.
So plus gamma 1 max is next April.
Next, yes.
Next is this room, and all of those 4 actions, the Q is 0.
Uh-huh.
So that's why we use
0.
now.
Okay.
minus the previous value of this room. That's 0. So also this one is 0. The previous value of this. So it's became minus 0.7. So that means the new value for this room became minus 0.5.
minus 5.
Yes.
Okay.
This one.
This was everything again.
Huh?
ده بدأ everything. Leave the example.
Or minus. For the next one,
Okay.
it's the same. So we will write that. The next, now we are in this room.
Okay.
Okay.
So we will write the same equation. So we will see. That's the repetition of the same one.
Every box is
Huh?
box.
Yes. Now training is going
Okay.
a path to reach destination.
That just example. Okay.
So يعني حد ما وصل للمدة
هاي اللي بين قوسين ليش يقسمون ليش تقسم بوينت 5
لا أنا
هم هذا هو كل اللي بين قوسين وناتج صفر
أي صفر.
اي لما تضرب في صفر هي صفر فنبقى من الجانب اللي هي مقابل 0.5 نتج 0.5
work minus 1 for
All movement,
for box.
all movement, any movement has reward minus 1. Punishment.
Excuse me. Movement in there, okay, minus 1. In there, minus 1. In there, minus 1. In there, minus
10. If we go here, it's 10.
Yes.
Reward 10.
Yes.
هستفيد من minus
So-
1.
so-
Let us go there, we will see that.
اقعد.
Let's also
اقعد يقول راح اسوي.
So now we are in this room.
هسه يوضح مثال.
Again we find.
Yes, again.
Imagine
No.
we may put the name for this one. No, we don't know.
Okay.
QSA. So we want to find. We select one of the actions. No different. Randomly we select actions.
أفهم عشوائي.
For the training, we go past.
Okay.
We finish the game. We run a game.
Yes. I understand.
With the game, we train the table. Then we start again. We finish.
Yes.
We train the table. At last, the table will be trained. So, we are here. Imagine we are going right. So, if we are going right, that means we are finding the zero.
Okay.
So, the previous value is 0.
Okay.
The 0.5 of the training rate, then the reward is minus 1. The next room will be this. The maximum of QSA for all 4 is the 0. So that's will be multiplied on 0 minus the previous value of this room is the 0. So that's why the same minus 1.
المفروض.
المفروض
بس هو يمكن فلاش مجرد ولا؟
رقم ثابت اللي عنده؟
لا هو هسه هاي معطيات
المعطى بالناقص 5 ينطي بالسؤال.
خلاص.
0.5 بين قوسين
ليش؟
أبدأ أقول له هاي 0.5
نضرب
هي تنضرب قيمة بين قوسين وقيمة بين قوسين صارت 0 من أضربها المفروض مو أضربها بيها وهاي بين قوسين مو أضربها بيها ليش
You
ما
have
خرجت
an
0
relation between this equation and this.
يعني لازم نطلع ماينس.
روح روح.
Why this minus?
قيمة زيرو. قيمة زيرو.
هي ترجمة بالتركي.
Yürübünün bu kabzlar altında yaptığı yürübüler kıymetleri öyle sıfır.
قيمة
No, no zero.
زيرو.
No zero. This is minus 5.
Minus لا.
This is 0, this is 0. Became minus 1.
ضرب بينهم.
ضرب.
يساوي 0.9 هاي صارت حتطلع في صفر.
لا زائد ضرب يقول زائد ضرب.
You say, sit down.
Stay.
See? Here. We have x plus 1 multiplied 0. That's x. When we write x plus y multiply 0, in that case it's 0. So this is x plus y multiply 0. We have x. Here we have minus 1, 0.9 multiply 0. Became minus 1.
زين هذا الاستاذ معرفة هذا الموضوع هاي الرسمة
هو ده يقول
هاي ايش هي هاي الآلة لا مو الآلة لا
So now we are in this room. Imagine we go down. Like this, down. So Q is A became for this room. Its previous one is 0.5. The same. I don't write the same. It's exactly the same.
Photo. I'm writing.
شنو لا يقول كلنا.
تمام.
I mean, for this room, exactly will be the same.
Okay. I know.
The previous one is the 0, the 0.5, the reward is minus 1, the 0.9, the base of these Q's is 0, all 4 is 0, so the base one is also 0. So the result is minus 1. So here means we will have 0 point. Now after that we are here. Also here we select one of the actions. Imagine we select the done. No difference. So we go down. Here we are going down. In that case it will be different.
يقول هاي الخطوة النيكست ما في اختلاف بس الخطوة اللي
Now we are finding is 0. The previous value is 0.
0.
The point the reward, when we are going down, we are reaching the destination and the reward is the 10. Because the game finishes successfully. So the 10 plus 0.9 multiply. So when we are with the destination, we don't have the next. So we don't rewrite the gamma and the max of the base of the next. That's the final of the game. So then we have minus previous value of this root is 0. That's 5. Now there's so one game is finished. Then we start next game to make it even more accurate.
شنو صار؟ قانون
بس
participant.
وين؟
هو المكان بصفر بالبداية.
اي تخيلي مثل اس
So,
اي ماكس زيرو.
Let's be clear in this book to write the next game.
Yes.
So imagine also we start from this point, also for this game. For the next game, also we start from this point. Q is A. Because taking the different name for the A's, like A's, S3, or S next, and so on, is difficult. I write for all of them QSA, but though they are not the same, here if it is QSA, for example, here is S cream. We take Q S cream. But we want to just find the numbers to put here. So I'm writing QSS to make it more simplified for writing. So here, and imagine we are going the same path in the next game. So we are going this way. The previous value is the previous plus the training rate is then reward is -1 because we don't list the distribution plus gamma. The base of the next room. The base of next room is 0. The -1 is less than 0. So the base is max is 0. So no difference with the previous one. Minus the previous value is it okay? So we will see what is the result. Here became 0. Here became positive. With this one became negative 0.5. So with this one became negative 2.5. And with this one became negative 7. Means the result is minus.
Okay.
So after that, we change the value of this to
Doctor,
let's do 40.
please take about why 0.5 is a minus.
This one,
Yeah.
it's a minus previous value. Previous value was minus 0.5.
But say what's after that is positive.
Because minus minus became positive.
Okay. So هي تقول ضربنا السالب سالب ونشوف سالب. It's okay. Thank you. You can continue.
بس نكتب هنا عطوة.
Don't be in a hurry.
No, relax.
We are going.
لأن ليش كرر 5 مرتين أو 0.5 كرر؟
So now we are in this room. Also, we are going to the right, and the equation will be the same, and the value also will be the same. But here in this room, the previous value is minus 0.5 plus 20. Inside, reward is -1. The base of the next room is 0. Minus previous value is minus.
بس انا بس ما تحصل جاما هاي الار الاولى والثانيه جاما 0.5 واذا الار الثانيه جاما بس الار ليش المفروض تبقى 0.5 دكتور 0.5 minus R.
Come here.
تعالي هنا.
R مو R.
This is previous value. For any room, we are finding it's not R. It's previous value of this room. We are updating this. We say what is in this room. This one.
هو الأس
We are updating this.
إذا ما فهمت
What
أقول.
is
فهمت العملية؟ يعني ايش كررها مرتين؟
that's the training.
0.5 ايش مرتين سوا؟
يقول احنا تحركنا من الخطوات.
المثال قبل ما كانت مرتين.
مو ده هذا. مو هذا اللي خلاص هاي سبوزان 10 راح نطلع منها مربع.
This is for the training.
لا 10.
Random.
مربعات. لعبة.
تدريب عشوائي.
اوكي. وين؟
Are you great person?
So now we are in this room.
Okay.
And we are going in the door. It's the same. Because we are finding this value. The previous value of this room is -5. And this is training rate. Then reward is -1 plus the gamma value multiplied the max of the next room and minus previous value of this room. Okay, minus 175. So here, imagine instead of going down, we are going left. So we are finding this. So it's became Q S A. The previous value is 0 plus training rate is 0.5. The reward is -1 plus the gamma is 0.1. The max of this room is 0 minus the previous value is 0. So became minus 0.5. So here became minus 0.5. Now we are in this.
Okay, continue.
Then here imagine we are going down. So we are finding this. It will be exactly the same.
Okay.
So this will be minus
0.5. بدأ صار كان صار رجع أي صار
So now we are here. Imagine we are going right.
كل يطلع قدام. Okay, cool.
We are going right. If we are going right, we write here the equation. So the previous value is 0. Plus
أنا بكمل.
the training rate is 0.5. The reward is 10. The gamma value is 0.1.
Okay.
The previous value is, sorry, the max of next,
Okay.
we don't need to write. Because when we reach the final, we don't have the next, so we don't have this. So minus the previous value is, so became, so this became up.
قوم اشرح لنا ثلاثتهم. اشرح لنا. ها؟ تقدر؟ بالعربي.
So
ما تقدر؟
if you see from,
شو؟
if you see in this point, we have the optimal value for these two rooms. It say us, if we are in this room, the base way to go down, because this is the maximum from this 4. Also, if we are here, the base way to go right, because this one is the maximum from the 4. After we continue these games, we will see all the rooms will have the optimal value. That means from 4 values, we find the best one to go. The maximum is the best way to go to reach the destination in the past or in the least time.
كم هذا الصور
أسرع طريقة للخروج من المنظمة.
تقدر تشرحها انت ولا ما تقدر؟
أقدر
مضابطها؟
لا الفهم أنا شيء أقدر أوضح شيء.
اي وضح وين المشكلة؟ خذها الصورة قول خذها الصورة بموبايلك. كان تكت فوتو؟ اوكي قوم وقف عليه خذ واحدة صحيح. تمام. واحدة اهم شيء واضحة بالكتابات. طفي لك داتا شو؟ تمام.
No difference. Any place you want, you start. At the last, you will find value for all rooms and the optimal policy. Means in any room from 4 action, one of them is maximum that continue in that way. You reach in the least time to destination.
She asked you, she told you and me, get me this example, okay, like this, for example. Because we don't time and you. This example like this.
من البرمجة ونقول تجيب ده ما دافع معي تريد تجيب هذا ليه؟ ما قلت له أسبوع جينا شيء ده طيب مو مثال عليه أقصد كل شيء امتحان ده إكزام ولا مدرسة كده الله كريم عم يدلنا لا ما في سنة لا ما يدري لا ما في حد ما تدري أنا قلت لك شو أنا
Yes, okay.
شو ما يدري من
Now we say, let's describe this. So we say difference of this, and this one should be less. So that's our error. What is this 2? The YR means the reward plus the total expected reward for the next state should be equal with the QSAs we described earlier. So if they are not the same, as much as they have difference, that much we have error. So the loss or error is difference of these 2. This one and this one. And if you remember in the example, we add that error to the previous value because we want to improve it. Imagine our scores are different. We want to make it equal. So we say I take 10, you take 15. We say the difference is 5. We say the difference is 5. I update my value, make it 10 plus, not 5, 2 and 5. Little by little, I want to improve to reach that. That's the last order. So, here is an example for playing card games. If you remember when was
Yes, I remember that.
there was a
Yeah.
So here we have, he described what is the state, action, and reward. State. For the state, when we have the rooms like the example we solved, the state is being in one room. But in the upper game, state is in which image we are. That's our state. So the state is image of the game in that time. That's the state. It means we are in this position, we are going, we are reached this point. So the whole image is our state in this time. Then if we are in this situation, whole image is our state. Next state and so on. So the raw pixels inputs of the game is our state. What's the action? What can we do with the control? Imagine it's very simple. Going up, left, and right, and back. And maybe also we have action of shutting the command and so on. But here, take it simple, 4 actions. And reward. So reward, there is a point here, right? Our reward is till this point. So how we implement that?
Network.
The upper game is like a video. In seconds, we have a slice of the video. So it takes 4 previous trains and take it, of course, do some pre-processing, converting RGB to grayscale, and also downsample means it's 1000 to 1000. 1000 row, 1000 row. So it's so much for to be stay. We make it half. 1 row we take, 1 row we don't take. 1 row we take. It became half. It became 500 from 500. That's called downsampling. And also we crush means there is a upper game. For example, the airplane is going. Airplane and neighborhood of airplane is important. So we cut just the area that airplane and the other points that's important is in cropping. The other area, for example, is jungle, there is a tree and so on. And it's not important for the game, just they are for the to make it the view better and look like better. So we don't need those areas. Then we use neural networks, CNN, for feature extraction. We will talk about this in the previous chapters. For example, here, if you don't see these videos and don't sit in the room and after class you didn't watch the videos,
Yes.
you don't know these things. So it will seem like strange matters for you. But if you be in class and watch the video after class, you are familiar with the CNN. What is the CNN? So after that, we have a fully connected neural network for classification, means usual neural network. So we have 4 outputs. Q, one of them like this, we have 4 outputs. One of them is for Q is A1. One of them Q is A2. One of them Q is A3. one of them Q is A4. For example, this is for going right, this is for the going left, this is for going up. So, and what is the state? The 4 frames of the other game view that we are in that point. That's the state. So we find 4 values, and each of them is maximum. That means if we are in this situation, for example, the right is maximum. It's say if we are in this situation, going right, we get the maximum reward. That's better to go right after training. So what we are talking here? If you remember, we have an example. We are filling a table, doing games and so on. That was an example you understand better. But in reality, we have a neural network, not a table. In neural network, we train the neural network based on our examples that we are going from starting till end of the game. We give into neural network is trained. After training, if we are in any point, it gives us 4 numbers, which of them is the maximum, that's the better action to do. You see, when the other is continuing with Arabic, 2 person is saying that will be better for you to understand. I think the Omar will come next week.
عمر هذا؟
شلون؟
هذا اسمه عمر كان يقوم يترجم؟
عمر اي عمر قل لي البرمجيات ما يجوا هالاسبوع سوفت وير بس بعد مش قاعد
After 2 weeks I will come.
عمر
1 week is past.
عز الدين
لا عمر عز الدين and حسين.
Okay. The next subject is the experience reply. I will talk about what is that. Imagine we start the game. I will talk to the table. So imagine we are doing a game from starting to finish to train the table. So if we are going the right, so our experience will be biased. Imagine we are training a dog in a home, in the room. In the home, there is some rules. So based on the starting the game, if you are going the right of the home, all our experience will be in the right of the home. So, because of that, when we start the game, we put our experience in a table. The name is experience. Experience the name. Then we start other game and finish it. We put it there. Then for the training the model, we take some parts of experience. Maybe it is 1 part from the right, 1 part from the left. So in that case, the training will not be biased. That is the experience delay. Experience reply. There is a memory. We put all the games from starting till end in the experience reply memory. Then every time we want to train the model, we take some the samples from that table and train them. So the training will be, in its time, will be from left, right, all parts, not one parts of the game. So it will not be biased. Let's say like this. Learning from that of consecutive. Consecutive means starting to end, we take those for training. Samples is problematic. Why? Because samples are correlated, means current Q value parameters determine next training samples. Means if we are going with the right, so the next samples will be in from the right of the So now we are going to pseudo-code up algorithm. Here is the pseudo-code of algorithm. At first, we say we make a reply memory, the memory we was talking about, the name D with capacity A, the memory that we put experience under that one. Then we initialize Q with the random values, like we initialize that tables with the zero, all zero. Then we do deposits. So, what is the deposits? Deposit, as we talked earlier, every deposit means training, hold the table, hold the models. Now, when it is n means n times we train. So, at first we initialize the state, means if we are in the table, we start from one point, from starting point or the second point, we start. If you are in Atari game, the first position, first video we see, that's our first state. So then we find processed from this process. How we find the process? As we earlier told in the example, we do pro-process. For example, we do convert RGB to grayscale, we downsample, we cut the image, just those parts that is important, that all parts. After we take the parts that is important for us, we put it with this name. That's the first state, our first state. Then we start from first of the game till end of the game. So at the first of the game, for first action, we do two jobs. We have two choices. Or randomly we select one action. Either we select randomly one action, or we select the best action. Why we do that? At first, the table is all zero. If you imagine, I write an example, at first I put all zero. If I want to select the best one, all of them zero, without them the best. So at first we randomly go on. That means we have to choose with the probability. We select randomly first action, or we select the best action. What is the best action? From those actions, which of them is the maximum, we go that side. So, now we find the action, we do action in the game, and we will see what is the reward and what is the next state. Next state, for example, we go right, we go other side of the video. So that other side is our next state. So now we have next state, and we process next state to find the t plus 1 means we count and so on. Then we have a transition. What is the transition? Starting from state t with the action t, we got reward t, and the next state is feed t plus 1. So we put this in memory. We don't use it for the training. Then, when we put memory, we have the transition in the memory. Every time for training, we take from the memory samples, means several movements. Then we train. How we train? As we do in the samples, the same. We find these values minus this one. So, this is the value reward for this action plus the Q for next state. So, reward plus if the next state is the destination, so that's enough. If it is not, the next station is not the destination, reward plus the maximum or best action that we choose, we may choose in the next state, we select it and we will have Q with that value. So now we subtract this with the Q, S, and A. Exactly the same we got in the example. That's our our loss. Based on that loss, that error, we update the values. That's us.
Bitti.
شو؟
Bitti.
بالله غلط.
Ne yapalım?
So, here is again, we want to write the codes and the contours for this game. Here, from the Python, at first we use the gymnasium. To use gymnasium, we should install it with the Python. If it is not installed, we do like this. To install the gymnasium, what is the gymnasium? Gymnasium is a simulator for the games.
Yeah.
So, we import after that gymnasium as G, means every time we write G means gymnasium. So we say gym.make, we write the name of the game. Here, for example, the name of that game is Cardboard Every game we want, we write the name, it will be like a simulator of that game. It make like this. So based on the simulator, we train and it will show as a visualized form for us. Till the time it's in vertical position, the game is on. So based on the velocity, it's try to keep it up. When it is up, the game is up. Continue. So at first we should install the gymnasium. What's the gymnasium? Gymnasium is an environment to simulate the games, like Atari game and so on. It's an environment for simulation of the games. So we install it, then we import it. As gym means anytime we use gym, G by M, it means gymnasium. Then we make a simulation environment for this game. The name of this game is Card Pool. So we say gym, make a new environment for the simulation of a game. The name of the game is now for the gymnasium and us, it's the card pool. So after that, environment is the simulation environment for the game of card.
Download file.
Okay, we'll send after we finish this. So for the modeling of the games, as you remember from previous session, we have a neural network. Input of neural network is the state. The output, if for example we have 4 action, 4 output we will have. In each of them we will have the probability to choose that action. For example, imagine our state is 4 state. So this state, then we will have a neural network. Output, if for example we have 4 action, we will have 4 outputs. So, for example, this output going left, this is going right, this is going up, this is going down. So, each of them is the probability if we are in this state and choose this action. الو سلام نتیزن یافزن انشالله نتیزن آردازن yarım saate gelsen Jack Class diye 248'den. Ve ile oraya oradan geçer soruyor. Very close. So, we write this one Q, this state, for example, is, and action, for example, action A0. For example, going left. For each of them, we will have an a value, that's the probability to choose that action. Each of them is the maximum, we choose that action. So, for example, if it is the outer game, and the state is the image of the situation, for example, image of this room, or image of the game, so this input state will be an image. For example, if the image it has 3072 pixels, this will be 3072. So this is the state, and based on the state, we train to model to choose one of the action that's the best choice in that state. For example, we are in a position in the game, so the best selection, best choice for us going to right. In that case, from those 4, that one that is related to going right will be the maximum. So, here we build that model, that neural network. It could be 1 layer or 3 layer, 4 layer, and so on. So here we will have n observations. N observations means the dimension of state. If state is an image, so 3072, for example, if the size of the image, the n observation is 3072. Then n action is the number of actions. If, for example, we have 4 actions, the n action is 4. So here, at first we build a layer of the neural network. The first input is the state. The size of first input is an observation. It's dependent on the game. So at first we didn't convert it to 4. At first we converted to 128. Then we will have a layer converted 128 to same number but encoded. Then we convert 128 to number of action. It is 4. If it is 4, here is 4. So we have 4 layers here to make it the model more complicated, more strong. Then it can model the complicated game also. So it has 3 layers. At first we converted the inputs, that's state, to 128. Then the second layer, 128 to 128. The last layer, 128 to 4. So what is that? Imagine we have a problem. So we have f(x, y). It's a function. Here is, for example, 1000 dimension. X, it has a vector with 1000 number. Here is 4. Means y is a vector with 4 numbers. We want to train this function with the neural network. One solution is this. We come and we build a neural network. Input is 1000 number, output is 4. This is one solution. But the other is this. We come at first converted 1000 to a thing between 1000 and 4, for example, to 200. Then we use other neural network. The input is 200, output also 200. It makes it the function more complicated, so that could model the complicated models better. So after here is 200 also, then we convert it 200 to 4. So we used more than 1 layers. It's more strong model. So if the data is complicated, it is more strong. That's it. So how we find this 200 or this one 120? It's subjective. There is not any rule for that. Also, after we build 3 layers, here in the forward we give them input. Input is state. The first layer, activation. We give to second layer, activation result. Then the result we give to third layer, and we return the result. The result is 4.
السلام عليكم. هذا انا ما ادري الموضوع شو، بس تعرفه هذا برمجه بالبايثون. ما ادري تعرفون شنو هذا؟ البيب تعرفون شنو؟ شنو هذا؟ شو يسوي؟ هذا مثل المدير بالبايثون تنزل من عنده المكتبات، تخاطبه باللغه البرمجيه تقول له نزل لي هذه المكتبه تشتغل عليها. تقول له نزل لي شي مكتبه اشتغل عليها، كانه شلون ذكاء اصطناعي موجود داخل البايثون، يساعدك تحمل به المكتبات داخل البايثون. تساعده تساله تقول له ايش قد المدير مال فيرجن مال التطبيق يجاوبك، تقول له فلان مكتبه موجوده لو لا يجاوبك، كانه ذكاء اصطناعي داخل البايثون خلاص. تمام؟ هذا اسمه بيب 3. هذا الاصدارات 1 و2 و3، هذا الاصدار الاخير مالته. تمام؟ المهم بس الشيء اللي ينزل يقول له انستل يعني ثبت لي هاي المكتبه. شلون تخاطب هذا الشخص المساعد مالتك؟ يقول له ثبتها، هاي المكتبه شنو شغلها؟ هو انسان شوفه على فد جيم ويسوي فد بيئه محاكاه وكذا، هيك الموضوع مالته. فحملها وراها شيء يسوي لها امبورت ينزلها للفورم مال الشغل مالتك. وهاي تتحمل ممكن يستخدمها بغير تطبيق، يعني عندك اكثر من برنامج احتمال فاتحه، فمن تقول له امبورت يعني انا حاشتغل بهاي هسه. استدعي لي اياها هي ومكاتبها، راح استخدم من عندها دوال. من نقول له امبورت يعني شنو ايش حيصير؟ يعني انا راح استخدم هاي هسه. تمام؟ استدعاء يعني انا راح اشتغل حاليا بهاي المكتبه. يعني انت احتمال مثبته 10 مكتبات، مكتبه عالج الارقام، مكتبه عمليات الرياضيه يعني، مكتبه عالج الصور، مكتبه عالج المحاكاه. فانت بالخطوه هاي مال الكود اللي راح تكتبيه هسه بتستدعين هاي وحتشتغلين بهاي المكتبه. تمام. هنا يعني انفورميشن يعني بيئه، يعني البيئه اللي حاشتغل عليها تشتغل ضمن هاي المكتبه. اللعبه هاي من نشوفون هاي العلامتين تو كوتيشن معناها هذا اسم للعبه، اسم للبرنامج. تمام. هذا هنا الكلاس مالتنا المودم اللي حنشتغل عليه، الكود البرمجي اللي راح يؤدي لنا الغرض اللي احنا بدنا نشتغل عليه. نجي لنا وارجع يقول لك اكو انا مثلا عندي هاي عمليه اريد اعالجها. انا كل ما ازيد عدد اللاير الطبقات شو يصير عندي؟ يكون النتيجه عندي اذا عندي التطبيق اريد اعطيه يعني اكثر تعقيدا. تمام؟ والنتيجه اريدها اكثر موثوقيه. وتعطيني نتائج مضبوطه 100%. ازيد عدد الطبقات بالذكاء الاصطناعي. فشو تكون المدخلات للطبقه الاولى، مخرجات الطبقه مدخلات للثانيه، مخرجات الثانيه مدخلات للثالثه، لحد ما تعطيني النتيجه طابق اكثر من فلتر. فالنتيجه تكون 100%. تمام. فيقول هاي العمليه اقدر اني عندي المدخلات الالف، وانا عندي الفانكشن الداله مالتي والمخرجات الافعال. انا اقدر اسوي هاي العمليه بلاير واحد وتعطيني النتيجه. هنا انا شوفي لل 200 الثانيه يلا اعطاني النتيجه، فاكثر من لاير الموضوع. تمام؟ هاي الفكره مال الطبقات. نيجي هنا التعريف من البدايه، هذا نشوفون هاي يعني ديفينيشن تعريف. نيشن يعني القيمه الافتراضيه الاوليه الى اخره. فيكون يعرف السير هاي حكي ذاك الكود بالاستدعاءات، ما يرجع يكتب الكود نفسه ويستدعيه مباشره. هنا يقول لك عدد الدايمنشن، عدد ابعاد الصوره مثلا بدنا نشتغل عليها. هنا هاي يكون قيمه افتراضيه، مو قاعده، لا على التعيين. وهنا الاكشن اللي هي الفعل اللي راح يصير. مثلا انت لعبه عندك جيم وعندك هاي يد قديمه بيجير، اعطيتي مثلا اتجاهين من الاتجاه اليسرى، فحيعالج العمليه وتعطيك النتيجه. تمام؟ هاي الاكتن الفعل يعني شنو حيعطي النتيجه. سياره سباق مثلا اليمين واليسرى الى اخره يعني. تمام. هاي هنا استدعاء نفس الكود. هنا اي شيء بالبرمجه بالكود البرمجي بالبايثون شيء يحوله الى الصوره الخطيه اللينير حتى يبدا يعالج به. يعني تعرفون كل شيء معالجه يحوله الى معالجه رقميه مصفوفه ويشتغل عليه. تمام. وهنا قلنا هاي قيمه افتراضيه بالدايمنشن، يعني انا هسه بالدايمنشن اريد 128. يعني يكون بين قوسين الشغل وقال لو يعني هذا الرقم كم دايمنشن. تمام؟ هيك تصير العمليه بين قوسين تشوفوها. يعني هاي هو مفترض انه انا اشتغل كل خطوه هالقد دايمنشن استخدمه واشتغل عليه. تمام. وهاي هنا يعني يزيد كل مره ايش قد 128. مثلا هو عندنا 1000 128 لو 128 مره ويعالج بهم لحد ما يكمل ايش قد هي القيمه الاجماليه من المعالجات عندنا من البيانات. نفس الحاجه نفس الموضوع. تمام؟ هو هذا وصل هنا وشرح وضح بالمخطط. تمام؟ وهنا الفعل من كل 128 من البيانات حيستخدمها. شنو الفعل اللي حيصدر عنها؟ شنو النتيجه؟ قلنا مثلا لعبه شنو راح يبني رجع يسرى قدم لقدام رجع لورا الى اخره تمام؟ بس انا كل البيانات ده اعالج كل مره قيمه افتراضيه قلنا ما لها علاقه تمام؟ وهنا اعطاك النتيجه النهائيه بصوره خطيه حتى يرجع ينفذها بارض الواقع على البيئه مال اللعبه هذا وهنا يكون التنفيذ مالته الفانكشن الاولى والثانيه والثالثه كانه يعيد الخطوه مره ثانيه هاي ريتر يرجع من جديد ل 28 ثانيه ويرجع من جديد ل 28 ثانيه. الحمام كم شغله لان ما عندي سوالف.
This algorithm is Q-learning. So let's say the Q-learning could be very complicated. In the Q-learning, we try to train how to behave in any state. So we should have any state like we are in this state, we are in this state. So in the real world, the number of states is infinite. If we try to train behave in any state, it will be very difficult and very complicated. So we have other choice to train policy. In the policy it say, if you are in up, you want to go down, do something. The policy we are talking, not any detailed state. So that will be better in the complicated cases. So we are talking about policy, not any state, and what to do in any state. We say if you are in this, for example, if you are in up, you are going down, do something. If you are in a state, there 10%, so if the person number is more than enough, do that. We are talking about policy, not states. So in the policy, we have an aim, an objective function. We say we try to find the policy that sum of the rewards be the maximum. Means starting from a point, sum of the reward till end of the game be the maximum. That's aim of policy also. So we are trying to find the theta, our policy, a table if you remember. For example, in some room it say just going up is acceptable. That was the optimal policy. So here it say theta is the policy. The base policy is the policy that make the sum of the reward maximum.
Here's the question, what's mean policy?
Policy means siyasat.
Okay.
Siyasat. For example, there is some rules. There is some super rule. Any country has.
Okay.
It say, for example, if it is like this, you can do like this. It's a policy, siyasat. It say, for example, if you have not hair, if you can do that. So that's for you, also for me. It includes more than one state. It includes lots of states. So you don't need to talk about any states. Because in some situation, the number of states is infinite. So you cannot use Q-learning. In Q-learning, we are talking about any state. We say if we are in any state, what we should do. But in the policy, we are talking about a siyasat, a policy. Then we follow that policy in any state. So the policy algorithm pseudocode is like this. At first, we select any trajectory. Any trajectory means the path, any path. Then the gradient to update the policy is this one. It has a mathematical solution to find this, but I eliminate that part because it's mathematical and will be difficult for you. So it is like this. It is gradient of the policy. That's the probability of any action in any state. So multiplied on advance. What is advance? How good this action? How we find how good this action in this state? We say Q value of state and this action minus value of state. What is the value and Q? Do you remember Q and P? I think you was not in class, you don't know this. So first I talk about value and Q. In the value, we are in a state, and we say if we are in this state, we expect some of reward till end of the game. How much is it? So that is the expected total reward we will achieve from starting this state. If we start from this state. But what is the Q? Q say we are in this state. But at the first we know that we go on left. The first action we know what is it. After we go the left, then we follow policy. What is the expected reward, total reward? We cannot. So what is the difference? In the value, we are in a state, and we say if we follow the policy, the expected total of reward, what is it? But in the Q value, we say we know first action. Maybe it's go left, maybe it's go right, but we say we are in which state and what is the first action. Then tell us the expected sum of rewards if we follow policy. So difference of this is how much this action is good, first action. Because here we fix the first action, here is not fixed. So difference of them is the how much, how far this action is good. So the update gradient for update of policy, it's saying how far action is good, and the gradient mushtaq of the probability of selecting its action means how far is good and what is the probability of that. This probability of that in this state, probability of this action. So based on this, we find the gradient, then we update that theta. That's the policy. We do this, we repeat till policy is finished. Common spread as you understood. Here we talk about that we use policy.
قبل ما هذا اعطيكم شيء يريحكم، هذا الموضوع كله ما داخل الامتحان الكود ذاك، يعني لان صعب تقول بس مجرد الفهم بس تفهمه، فيعني هذا الفهم ارتاحوا بس تفهموه. هنا شنو يقول لك؟ يقول يعني عندنا شغلتين، عندنا الفاليو عندنا يقول يعني ذيك الفاليو شو يقول؟ يقول الستيت الحالي، معناه ستيت حالي. الحالي شنو؟ انه مثلا انا واقف هنا حسب الشرح مالتي، انا عندي كل الخطوات وكل يعني الاكشنات عندي متاحه. ماكو خطوه اوليه انا مجبور عليها. تمام؟ بالفاليو بالستيت. هنا شنو؟ هنا تكون عندي خطوه اوليه اجباريه. مثلا لاعب باللعبه من تبدا اللعبه لازم واقف بالفرع، فلازم يطلع من الفرع حتى تبدا اللعبه. يعني الخطوه الاولى اجباريه، يعني ما يروح يمنى يروح يسرى، يتخذ خطوه معينه، يصعد ينزل، يعني هي للتوضيح يعني مو شرط هيك، بس انه انت عندك خطوه ويا التنفيذ اوليه اجباريه. تمام. اوكي. زين. هنا يقول لك follow البوليسي شنو هي السياسه؟ مثلا يقول لك اني عندي مثلا ستيت وعندي حالات الكل حدث الى شلون كل فعل الى رده فعل. السياسه هنا يكون موضوع شمولي اكثر، انه مثلا الدوله شلون تتعامل ويا المظاهرات. هنا ماكو الدوله تروح تشوف المظاهرات شنو سببها وسلميه، اكو اجراء سياسه للدوله مباشره ان يطلعون الشباب ويوقفون ويسدون الطريق كمثال يعني للتوضيح. سياسه عامه بغض النظر على اولويه الحدث هذا شنو هو، مهم، صحيح، مؤذي، مفيد للدوله، وهي سياسه الدوله عكسها، سياسه يكون هذا شمولي اكثر. تمام. الداله هاي اللي يحكي عليها، الداله والمشتقه، شنو غرضها؟ اول شيء تعطي شنو فائدتها؟ يعني ايش قد هي مفيده؟ وثاني شيء ايش قد بعدها عن السياسه هاي او عن الرول او القوانين مال السياسه هاي. هذا اللي قال عليه ما يعني ما داخل، ما مطلوب منا حفظ. هاي اسمه دلتا طبعا. هذا لا هو الكود هذا كله شرحه مجرد لا
بس للفهم.
لا للفهم، وهذا اصلا بدايه الكود. فهذا اللي شو حتى انا استوعب شوف الكيور عن الفارية، بس قلنا هاي فيها خطوه اجباريه، والستيت والفارية هي خطوه مو اجباريه، مثل ما قال التوقف ممكن عندك هوايه اكشنات وما مطلوب منك خطوه رئيسيه. هنا المشتقه جراجين المشتقه ايش قد بعدها عن الاحداث هاي او عن النتيجه اللي ممكن انا اوصل اليه. يعني هي يعني قريبه من الواقع اللي انا مو حسب شو مكتوب. مثلا هنا انا مثلا اريد افوز اللاعب، فهذا المشتقه حتعطيك قيم ايش قد انت نسبتك تفوزين وايش قد نسبتك تخسرين. تمام؟ اي تمام. واللي هي توضيح اي من يكمل النتيجه مال هاي المعادله شيء يسوي قيمه افتراضيه بالبدايه ويضيف تعرفون انتم بالكودات. اول شيء مثلا اريد اجمع 1 زائد 1، حاسبه ما تعرف شنو زائد 1، تحطين قيمه صفريها وتجيبين واحد تحطين بها القيمه الصفر وتجيبين القيمه الثانيه تحطيها فوقها تصير 2.
If you remember, for update any weight in neural network, we do the previous value. It was minus. Here is positive, no difference. It could be minus. The step after training, this is gradient of loss based on the weight. The same.
تمام. يقول هاي يعني هي اصلا قيمه يعني فارغه، والاشاره تعرفون اللي قدامها تاثر وراها تاثر، فهاي زائده وناقص هي اصلا قيمه افتراضيه مثل ما انتم فاهمين انه بالعمليه بالبرمجه مثلا قلت لكم مجموعه 1 زائد 1 تعرف الست قيمه فارغه واجيب احط له 1 انه بعد اضيف فوقها 2 يصير قيمتين يعني معناها 2.
If it is minus, we say gradient ascent. If it is positive, we say gradient ascent. Based on gradient, we improve it. If it is minus, here in this situation, it's gradient ascent. We do previous plus. If this minus gradient descent. The name of the method is gradient.
اي انا نفسي بس انا تعرف شيء ياثر على المعادله اللي هي كمعادله ما ياثر عليها شيء، ما ياثر على النتيجه يعني. اي تمام، يعني مجرد للتوضيح انه استخدمها هذا مجرد بالحالتين الافتراضيه، بس هي كمعادله رياضيه ما تاثر على النتيجه الموجوده. تمام؟ يعني
هاي الصفحات الاخيره بس للفهم.
هو حكى على الكود هذا، القبل ما اعرف انا اصلا مش مطيقه، فبعدين اذا تريدون نسير. تمام هسه؟ اوكي.
So, we have an approach that is actor critic. Here, Q-learning and policy is mixed in an algorithm. The name is actor critic. Actor is policy, critic is the Q-learning. Based on the policy, we select an action. Then, based on critic, we say this action how is it? Is it good or not? So, it has two networks, actor and critic. The actor decides which action should be taken. Critic informs the actor how good was the action and how it should be adjusted, updated. So, here is the gradient for the policy. It's exactly the same. We say what is the probability of one action? Then it say how good is it? So this is the sum of the probability of one action in this time, in one time, multiply how good it is. Then we go on next time. What's the probability of each action and how good is it? Then we sum them and take the average. It became the gradient. So we update it with advanced function. This advanced function means how good is an action. So we put it here, and this is the probability of an action in any state. But here, for the advanced or how good one action is, it uses this equation. It say in its time, we are in its time, this time, then we take one action, go left. So what is the reward of this action, first action? Plus value for this state. It became Q. So this Q in the first page, it was Q minus V. But it is open, write it like this. It say reward of first action plus value in the next action minus value in the first action. It's the same. I describe here. Q, state and action minus value, state and action. So the previous one was like this. You describe it here. Q minus V. And this one also is the same. Why it is same? It say if we are in first state and we do first action, what will be the reward after this? So it means we have the reward for first action and the sum of reward after that. So it say reward for first action plus the value for next state, means after that the expected sum of the rewards, minus this one, the value for the first state. So difference of them is how good is one action. Are you returning to first bit? Here is Q minus V. Then it is right, this one also with the value. How it is right? It says QST means we are in this state. We want to find the total reward after this if we know first action is this one. So we want to write this with value also. We say reward for the first action plus reward for V for the next state. Means from next state, what is the expected total reward we can have? It's the same, no difference. So it's right like this. Can't describe it more than this. I will describe it.
هنا نفس الكلمات موضح لك اياها. هنا بوليسي اللي قلنا عليها السياسه، وهنا اللي هي الكيو اللي قلنا عليها. تمام؟ اللي قلنا عليها انه يعطيك حاله اوليه تقوم بها وبعدين تقوم بالافعال وراها. تمام. هنا اكو عندنا فد شبكه معينه او شبكتين العفو اللي هي السياسه يعني نقدر نمثل هذا اللي هي السياسه والتقييم مال هاي السياسه تصير تمام؟ السياسه لا بعد اسالك يعني نقدر نقول هو شنو يقول يعني الضروره هسه الكل اجي اشرح لكم تمام. هنا شو يقول لك؟ هنا شو يقول لك؟ السياسه تحدد يا فعل انا اختاره تمام؟ احنا قلنا السياسه الخطط العامه نقول مستقبليه فهنا هي اللي تحدد وتكتشف منو وش يعني اي من الافعال راح تختارها تمام. هنا التقييم هنا يختار هي افضل اختيار يسوي له ادجاست يعني الاختصار او الاختزال ياخذه يختزله تمام. ادجاست يعني تمام.
Actor is policy.
Policy.
Is policy. The critic is Q value. Q value can say if we are in one state, which action has more probability to be chosen.
تمام.
So policy say now you choose which action. The critics say based on Q value, QSA. This action, how it is it? How it is? Is it good or not? If it is not good, say policy change your policy.
Okay or not? Change.
Also adjust. Say the policy, you are not good in the selecting policy, change your policy.
Okay. Wait. للتوضيح المثالي مرتين نقدر نقول هنا المدير وهنا المساعد مال المدير تمام. المدير هنا يتخذ قرار يقول خلي الموظفين يطلعون ب 12 طالب. هنا المساعد مالتي شو يقول لي؟ يقول لي لا استاذ اذا طلعت ب 12 حيأثر على سير العمل. هذا شيء يحدد انه يبقى القرار ولا غيره. للتوضيح كمثال من يمين تمام؟ اوكي. اوكي. هنا شنو بعد؟ شوف هنا فد شيء حلو بالهذا. احنا ايش عندنا؟ عندنا حاله اوليه وعندنا خطوه اجباريه وعندنا بعد الخطوه الاجباريه كل الخطوات اللي ممكن اتخذها. هنا شو يقول لك؟ يقول لك هنا كل الخطوات.
This one and this one is the same, no difference.
Okay.
Just Q, instead of Q, we write reward for first action plus reward after first action means value in next state.
اوكي. هنا شو يقول لك كل الخطوات اول شيء بعد شلون يبدي العمليه البرمجيه تصير بالعكس هنا مثلا انا جيت دخلت وقفت هنا اول شيء كنت واقف بالسبوره اتخذت خطوه وقفت هنا وعندي افوت بهذا الممر وهنا واطلع عندي قد خيارات 3 خيارات هنا كل الخيارات المتاحه وهنا الخطوه الاولى وهنا الخطوه الافتراضيه الاوليه خطوه افتراضيه وخطوه اولى اجباريه وخطوات بعد الخطوه الاولى تمام خطوه اوليه خطوه اجباريه وخطوات بعد فهنا الكود يعطيك نتيجه ويقول لك انه انت ايش تختار من عندهن يجي ياخذ كل الخيارات المتاحه ينقص منها الخطوه اللي سويتها الاجباريه ضاعت من ضمن الخطوات المتاحه ينقص منها الحاله الاوليه مالتي وين كنت واقف على السبوره كنت قاعد وجيت وقفت ورا ذا قبر يعطي نتيجه يقول له شنو الضروره اللي انت لازم هسه تسويها تمام هذا عمل الكود صوره مبسطه اوكي
So, this is the pseudocode for the actor critic algorithm. At first, we select state and action using policy. So, I say that we have 2 models, policy model and Q value model, means actor and critic. For both of them, they are neural network. At first, we put initialized weight. For example, we put all of the weights 0. We initialize. So when we use the actor or policy, we use the initialized version of them at first. Then as we go on, they improve and they give the good result. So at first we select step and action from policy network. Then we find the advantage of, what is the advantage? How good is this action? How good is this action? We say Q value minus V value. Q value, in the Q value we have the state and first action. We find the total reverting end of the game. In the V, we have not first action. We start from state and we find the reverting end. So difference of them is how good the first action. Because difference of them is in the Q we have first action. In the value V, we don't specify first action. Anything is possible. So when we specify the first action, we say how the reward improve. That's our advantage. So we find the advantage. Then we update all of them with this one. For the optimizing, we multiply the advantage on probability of that action, then we sum it. But in the Q value, if you remember, in the Q value, it was the R gradient. We listen to that part. Yeah. This was difference of them was R gradient to update. I don't know if you remember or forgot it. If you didn't it, you forgot it. The Q value, this Q value. The difference of two states means R gradient to update the Q value. So that means this one exactly the same is used for update the W. W is for Q value.
Weight for the Q.
So weight of the Q was the difference of Q and V.
Yes, I know.
That was it.
Yes.
But here in the policy, that's the course of this session, it's multiplied on probability of that action and summed for all one. Became the gradient. That's why for the policy this is used, but for the Q value, exactly the advantage is used for the update.
بالذكاء الاصطناعي نروح نرجع للموضوع هذا اللي ما ادري انا اكثر مره انبه يعني اشرح عليه ارجع عليه الويت. تعرفون شنو الويت؟ تعرفون شنو الويت؟ معامل الخطا بالذكاء الاصطناعي حكينا عليه بالمعالجه الصوريه وشلون يحدد البرنامج هاي بالزون هاي قطه هذا كلمه الويت معامل الخطا هذا مهم كلش يعني هاي نقطه كلش مهمه بالذكاء الاصطناعي وبالان ان. زين هي هاي تعتبر يعني عمود الفقري مال الان ان هي معامل الخطا اللي هو يطلقوا له ويت علامته دبليو. تمام؟ هذا معامل الخطا ياخذ النتائج خلينا نقول النتائج المتاحه ينقص من عندها التوقع مال البرنامج ويعطيك ايش قد البرنامج يقدر يحدد لك هذا الموجود بالصوره شنو اذا كنت انت طالب من عنده يحدد يقدر يعطيك انه هذا الفعل اللي تسويه زين لو مو زين الك يعني عائديته زين لو مو زينه. شلون يقدر البرنامج يقدر يجاوبك على هيك اسئله؟ عن طريق معامل الخطا. تمام؟ معامل الخطا اللي هو يصير عن طريق المعالجات لاير ولاير ثاني ولاير ثالث نفس العمليه. هاي اللاير قلنا معالجات كلها يشتغل ويت رقم 1 ويت رقم 2 ويت رقم 3 كلها شغلها بالويت. هسه عرفنا هذا شنو ويت. هنا نفس الشرح للاعاده يعني نفسه انه انت عندك البوليسي السياسه وعندك الكيو اللي هي اكو خيارات بعدها مجبوره بالخطوه الاولى يعني ما تقدرين انت من البدايه تاخذين كل الاحتمالات مجبوره تاخذين احتمال اولي، وبعد هذا الاحتمال اللي هم فارضين عليك اجباري تقدرين تروحين هاي الاحتمالات. طبعا هذا مجرد يعني فد اساس الشغل معين هواي بعدين، بس احنا بدنا ناخذه كفكره فهم يعني. والفاليو اللي هو انت تقدرين من موقعك تتخذين اي قرار بدون ما تنجبرين على خطوه اولى. هذا صوره عامه. هنا نفس الشيء شرحنا قبل شويه عليه، انه اني قيمه افتراضيه مصفره ما بيها اي نتيجه، وعندي على مود اني اخذها شو يسموه هذا مثلا اي يساوي من 1 الى كذا، فالمتغير زين اضيفه ويا قيمه فارغه وتصير، وبعدين هذول الاثنيناتهم ينضافن اذا عندي قيمه ثانيه او ثالثه كعمليه برمجيه اوليه تعتبر. تمام. نجي هنا اول سويت اللي حكيت عليه بالبدايه لانه هو هذا اصلا المهم، انه هو شلون هذا التطبيق ده يقول لي للبوليسي انه هذا زين لو مو زين، باعتماده على الويت اللي هن شنو ذني اللايرات اللي يكونن بالضمن الفورم مال البرنامج مالتي، اللي هو شلون حيقول له مثلا هذا الاحتمال مو صحيح مو ضروري، يعني شوف ناس الكلمه اللي يستخدمها انه هو جود اور نو، بس هو شنو ضروري او مو ضروري، يعني انا الضروري افوت منها من البدايه وبعدين افوت منها. تمام؟
يعني مثال مش بسيط، يعني شلون بالنسبه للاستاذ اول خطوه اجباريه انه لازم
يطلع من القاعه.
لا لازم يدخل القاعه.
تمام.
انا يبدي بالمحاضره.
شوف انت بامكانك تطلبي الدكتور لازم يطلع من القاعه كخطوه اجباريه، يريد يروح الغرفتين ينزل منها لو يفتر منها.
هذه صارت اختيار.
تمام، هذا كيو. الفاليو الدكتور من هنا يحدد كل يقدر يطلع، يقدر يجوز ينزل من هنا، يقدر يبقى قاعد بالقاعه. تمام؟ يعني شنو الفرق الفاليو عن الكيو؟ الكيو لازم يطلع الدكتور من هنا وبعدين خياراته ينزل منها لو منها. الفاليو لا، هو هنا يبقى يطلع منها لو يطلع من الباب وبعدين. تمام؟
So, in full of this chapter, we have two algorithms, the policy and Q value. Q value, the name here is critical algorithm. We talked in previous session. We say in the Q value, we find if we are in any state from actions. For example, we have 4 actions. Each action will have a probability to be chosen if we are in one state. Then we choose the action with the most probability value. Means the action that is the best action between those actions. We choose that. That was Q value. For the updating the Q value, this one, we use just advanced function. What is the advanced function? We say difference of Q value in any state with one action and V value. Difference of them is their advantage. What does it mean? Q value saying if we are in this state and V is specified first action. But in the V, we say we are in this state. We don't specify first action. So in both of them, we say what is the expected total reward till end of the game. So what is the difference between them? In one of them, in Q, we specify first action. In the V, we didn't specify first action. So difference of them, in one of them, we got the reward 120. In the V, we got total reward 100. The 20 is difference. So how far this difference is more, the advantage of first action is more. So that's the difference or gradient we used to update the weight for the Q value. This means the neural network is used for Q value. We talked about in the first session. So here, what we are doing, here to update the policy, we sum we sum a factor for all of the times till end of the time, end of the game, till t. So what we sum in each time, we have for the factor the multiplication of how far this action is good multiplied on probability of selecting this action. Because, for example, we have 4 action, we say probability of selecting this action multiply on how good is it. Then probability of next action, how good is it? It became expected value. Because it's soft, it's not hard, like fuzzy plastering. We can specify which action to take. We say each of them has probability. We select each of them with the probability of that, multiply on how good is it.
We can say best choice.
Exactly. We select based on the probability of each action and say which of this action, how good is it? We sum all of them, it became the gradient for the policy. That's. So now you copy the next chapter.